Hello and welcome everybody into another entry into the Praviti Cinematic Universe. I'm your host, Mr. Praviti. Welcome in there, out there, all around the world. Find the length of the hypotenuse of the given right triangle pictured below. Some key terms here. You're going to need to know what a hypotenuse is. The hypotenuse of a right triangle is the longest side of that right triangle. So when we have a right triangle, meaning it has a right angle in it, it has to be a right triangle. Its legs are the two sides that I'm highlighting in red here that make up the right angle. And we call those A and B. Those are the legs of the right triangle. And in yellow here, I'm going to highlight the hypotenuse. The hypotenuse is always opposite from the right angle. It does not touch the right angle, and it's the one side of the triangle that does that. So they ask us to find the length of the hypotenuse of the given right triangle pictured below. In this case, our A and B, our legs are 5 and 12, and our C is our hypotenuse, and we don't know what that is. The Pythagorean theorem says this: a squared plus b squared equals c squared. If you do not remember at all or don't have this as a refresher, the Pythagorean theorem, what are you doing with your life? Just kidding. But the Pythagorean theorem is one of the most famous and important theorems in all of mathematics, especially geometry, and it says that for a right triangle, a squared plus b squared is equal to c squared, with a and b being the legs and c being the hypotenuse. Okay, so let's actually do this. The Pythagorean theorem says a squared plus b squared equals c squared, so let's plug that in. A is 5, so we'll do 5 squared, plus b is 12, 12 squared, equals c squared. 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144, and we're adding them together. The total is 169. So we'll get now c squared equals 169. In order to figure out what c by itself is, this is c squared, it's not c. Clearly this length is not 169, that's referring to the c squared, the area of a square, 169. Well, how do we find out what c is? We simply square root both sides, because square rooting is the inverse of squaring, so c is the square root of 169, which happens to be 13. So the length of the hypotenuse here is 13. They don't give us any units for this, so we'll just leave it as 13, but normally you might have it as kilometers, 13 meters, 13 centimeters, 13 inches, feet, whatever. 13 units of length. What we're saying here, to interpret that result, is that the distance from here to here is 13 units. We don't know what units they're using, but 13 of whatever units it is. Let's do one more example, just so you can see the technique again. We identify our A and our B and our C. Remember, A and B make a right angle to each other. L shape, perfect L shape. You know that A and B are A and B because they have a right angle, 90 degrees. All right, so we do a squared plus b squared equals c squared. I'll start off writing down my formula. A squared would be 20 squared. B squared would be 21 squared equals c squared. This is 400 plus 441 equals c squared. Remember, to square something is multiplying it by itself, so I'm just doing 20 times 20 to get this, 21 times 21 to get this. Total result, c squared, is 841. Square root both sides, and you get c is the square root of 841. which is 29. 29 times 29 equals 841. And so the length of the hypotenuse is 29. C represents the hypotenuse's length. Simple enough. They said our answer should be an integer. We continued to get integers for our result. What does integer mean? That word means whole number. If you didn't know that, write that down. Whole number. Integer means whole number. The word integer means whole number. All right, let's do one more example from part 1. Find the length of the hypotenuse of the given right triangle pictured below. Round to 2 decimal places as needed. Now, this is one of those examples where we're not going to get an integer because we're going to need to round to 2 decimal places. We could get an integer, it's possible, but most of the time we will not. 2 decimal places, reminder of how to round to 2 decimal places. Let's say I had a number like 8.695.312, blah, blah, blah. To do 2 decimal places, I have 1, 2, and then I draw a line after the decimal point. So this is a decimal point, 2 decimal places. And then I look at the next number. The next number after that line is a 5. If the number is 5 or above, then this number goes up by 1. So this will become 8.70. If this was, say, 68, then this would have become 8.69. That's how you round to 2 decimal places. If you don't know that technique, please let me know. It's a very important everyday skill that you absolutely need to know. Have me come around and show you some examples. Make sure that you can get fluent in this very quickly. All right, find the length of the hypotenuse. We are again doing a squared plus b squared equals c squared. So this is our a, b, and c. 9 squared plus 5 squared equals c squared. 81, 25, add them up, 106. So c squared will equal 106. Whenever you have something squared equaling something, then to get it by itself, you just square root both sides. Square root of 106. And this would be our answer, except for the fact that they say round to 2 decimal places. So let's do the square root of 106 in a calculator. In a calculator, we get, and if you don't know how to get this on the calculator, please just ask somebody near you or ask me. 3 before me, please. Square root of 106 is 10.29563, blah, blah, blah. Then we only need 2 decimal places, so we'll draw our line there, 2 spots after the decimal point. Our 5 brings us upwards. Remember, if this number was less than 5, if it was 4 or below, then we wouldn't take it up. But we do round up in this case to 10.30. And so the length of the hypotenuse is 10.30. Or, if you prefer, you don't need to write that 0, just 10.3. But since this has 2 decimal places, we'll often write the 0 there, just to clarify that it's 30. All right, those are a few examples. Next, we're going to go into how you do this with simplified radicals, and simplified radicals. So stay tuned for the next one. But first, you should go into part 1 of practice 1.25. Practice 1.25, part 1.